Hi friends, welcome to my YouTube channel Victory Academy. This is another coding lecture from our coding series. Today's problem is container with most water from the LeetCode. For more such content, please do subscribe and click on bell icon to never miss any update. So let's start coding. Today's problem will be container with most water from the LeetCode. It is one of the best problems in the LeetCode, and here we can use a two-pointer approach to solve the problem more efficiently. So let us try to understand the description of the problem more. Here we are given an integer array height of length n, and there are n vertical lines drawn such that the two endpoints of ith line are I comma 0 and I comma height. And here we need to find the lines that together with x-axis form a container such that the container contains the most water. And here we need to return the maximum amount of water a container can store. By seeing this, it can be a little confusing. So let us try to understand more with the following example. In the example 1, we can see there are given heights, and from the given heights, we can see 8 is the maximum height and 7 is the second maximum height. And here they both are separated with a distance of 7. So the maximum area which can be accommodated here is 7 into 7. So that's how we can figure out the maximum area a container can accommodate. If we check the second example, there are only two elements, 1 comma 1, and the maximum height and the width is 1. And the maximum area that can be accommodated is also 1. So the output will be 1. And here we can, by seeing this problem, it can be quite difficult, but by using two-pointer approach, it will be very easier to solve. So let's try to understand the problem more with a presentation as well. So let us try to understand the problem more with the following presentation as well. Here we are already having an input array and output of 49. So to calculate the maximum water a container can accommodate, we need the following parameters: minimum side and the maximum area. The minimum side can be calculated using the minimum heights of left and right pointer, and the maximum area can be calculated using the given formula. And here we will be using a two-pointer approach, which means we will be taking two pointers left and right, and we will be comparing both of them. So the left pointer will be at the start of the array and the right pointer will be at the end of the array. So now we need to find the minimum side. So here we can see the minimum side between both left and right pointer is 1, and they are separated with a distance of 8. So the maximum area accommodated here is 8, and that will be stored in the maximum area variable. And now, since the left pointer value is less than right pointer, it will move further, which means the new left pointer value will be 8 and the right pointer will remain in the same place. And now the minimum side would be 7, and they are separated with a distance of 8 minus 1, which is 7. So the maximum area accommodated here is 49. And now the minimum value is the right pointer, which means the right pointer will move towards left. And now the new right pointer value is 3, which is the minimum side as well. And the area accommodated here will be 18, which is less than the earlier value. So the maximum area value will be remaining same. And now the right pointer value is less than compared to left pointer. The right pointer will move further. This process will continue this process will continue until and unless there is a new maximum area value greater than the current maximum area value. And once the left pointer reaches the right pointer, that means the iteration has been completed and we will be remaining with the maximum area here. So the maximum area here is 49, which is between the 8 and 7. So that will be written. So let us try to implement the following thing in the coding as well. So let us try to implement the approach in the LeetCode as well. Here we are already having a predefined class called solution and a predefined function called max area. And let's try creating two pointers LP and RP and assign them values 0, len of height minus 1. And here we are also creating a variable called max area and assign it to value 0. And we will be iterating the array until and unless left pointer is less than right pointer. And here we can see that the minimum side would be calculated as min of height of LP comma height of RP, and max area would be calculated with the following formula, and every time the max area would be updated. And now we will be checking if the height of left pointer is less than the right pointer, which means the left pointer will be moving forward towards the right, or else the right pointer will be moving towards left, and at last we will be exiting from the loop and we will be returning the maximum area. So let's try running it. So when we try running it, we are getting all test cases have been passed in the runtime of 60 milliseconds. And now let's try submitting it as well. When we try to submit, here we can see the runtime is 553 milliseconds and the memory is 29 MB, and it is one of the best approach to solve the problem. So this is the approach to solve the most water container from the LeetCode. That is the optimal approach to solve the container with most water problem from the LeetCode. For more such content, please do subscribe and click on bell icon to never miss any update. And please suggest any coding problems which you want me to address in the next lectures as well. Thank you. Signing off, Venkatesh.